So now we discuss the architectural views. Architectural views. What views or perspective are useful when designing and documenting a system architecture? So this is a main question. So there is a suitability of particular view that we can select it for a particular system. What notation should be used for describing the architecture model? Each architecture model only shows one view or perspective of the system. So architectural views. So there are different views from which we can analyze the different architecture, particular architecture. One is a physical view, the physical view, and then logical view, process view, and then deployment view. So these four combinedly are called 4+1 view model. So 4+1 means four different views are combined as a one view. A logical view shows the key abstractions in the system as an object or object classes. A process view shows how at runtime the system is composed of interacting different processes. So as you know that when process is under execution, so process is normally composed of different interacting processes, or we can say different interacting processes combined as a one process. A development view which show how the software is decomposed for development. This means here at this stage when we are finalizing the architecture, we have not started coding yet, but we are finalizing the architecture, and then after architecture is finalized, we start then implementing the that software using particular coding tool. So development view shows how then software is decomposed based on the particular architecture pattern. A physical view show the system hardware and how the software components are distributed across the processors in the system. As you know, the software run only on the hardware. The PCs, servers, client side systems all comes in the physical view. So we must have to analyze the physical infrastructure, the development view, the process view, and logical view before we go to the architecture pattern. Now come to discuss the architecture pattern in detail. The patterns are a means of representing, sharing, and reusing knowledge. Architecture pattern is a stylish description of good design practice which has been tried and tested in different environment. Here I will say one important thing, that experience count here very much. If there is a experienced designer, so this means designers must have worked on several projects in the past, so they must understand the nature of the product and which particular architecture pattern is suitable for the particular system, software system. It is known easily when a designer have experience. So suitability also comes. Not all the patterns are suitable for particular product, or we can say that particular product is not bound only to the one architecture pattern. It is possible that a particular product is designed on two pattern, more than one pattern. So which pattern is selected? It is a task of designer, and obviously experience counts. Patterns should include information about what they are and what they are not useful. Patterns can be represented using tabular and graphical description. So we can draw it using graphics or in tabular form. Now the important architecture pattern which are nowadays used mostly by developer is model view controller or MVC pattern. It is interaction oriented pattern. So what now come to discuss briefly about what MVC is. It separates presentation and interaction from the system data. The model part of the MVC means model view controller. The model part of the MVC is basically responsible for storing the system data or maintaining the data. So it separates presentation and interaction part from the system data. The system is structured in three logical components that interact with each other. The model component manages the system data and associated operations on the data. Second, the view component defines and manages how data is presented to the user. So the view, as the name shows, view means the view component or front end. In software development terminology, we can say front end. So the front end is basically responsible for viewing the data. So the view component defines and manages how the data is presented to the user. The controller component manages user interaction, key press, mouse clicks, these events. So this is, we can say, the backend development. The backend development, controller, the algorithms, all comes in the controller component. So the purpose of view is to watch the data, to enter the data through the view, and then controller manage all the processes between the model and the view component and pass these instructions to the view and model. So the instructions and data are passed either to model or either from the model to the view. So data are entered from view to the model or from model to the view. So which component is then responsible for doing all these movements and controlling actions? Controller. Now the example is also given in this slide. When to use? Used when there are multiple ways to view and interact with the data. Also used when the future requirements for interaction and presentation are unknown. Or we can also say that the view or controller component can be replaced. For example, in future, if we don't replace the model view, but rather we want to replace the view component of the web development application, for example, so we can easily detach and we can easily replace it with some other view, design and develop in other tool. So there is a less coupling among the model, view and controller all parts. So this design pattern, architecture pattern is applicable in that case where we don't know the future requirements. Advantages: it allows the data to change independently of its representation and vice versa. Support presentation of the same data in different ways, which changes may be in one presentation shown in all of them. Disadvantage can involve additional code and code complexity when the data model and interaction are simple. So this is a disadvantage, that we must have to learn some more coding, or we can say we must have some expert on code level to implement this pattern. This is the organization of the model view controller. You can see this is model, and data is passed either to view or from the view. View generate state query, and then change notification is passed to the view. But who is responsible? Controller is responsible. View request model updates send user events to controller, and then through the controller all these transfer and changes of data. And obviously when we deal with the software or process, we must have to deal with the data, and changes in data are expected anytime. Either new data comes, either deleted, either many operation can be possible. So which component is responsible? This controller. So controller actually play a role of bridge, maps user action to model update select view, and state changes are informed to this model, and data is here. Web application architecture using the MVC. Now you can see browser view is operated using the browser, or browser connect with the view through browser, any browser. We can see example of Google Chrome browser. So we put some view address or website address, and then view comes. Dynamic pages are example of view. Forms or dynamic pages or static pages are all view. And then HTTP request processing, application specific logic, data validation. So through browser we can control all the actions. And which component is responsible? Controller. And database is here. Business logic and database are already here. Now come to discuss layered architecture. It is used to model the interfacing of the subsystems. This means system is divided into subsystems. For example, subsystem 1, 2, 3, 4. In layer-based architecture, subsystem 1 is interacted with subsystem 2, 2 is interacted with subsystem 3, and subsystem 3 is connected with subsystem 4. And when data has to be passed from subsystem 1 to 4, so it comes in a layer. It organizes the system into set of layers or abstract machine, each of which provide a set of services. It supports the incremental development of subsystems in different layers. When a layer interfaces changes, only the adjacent layer is affected. So this is the advantage. However, often artificial to this structure system in the way. Now come to description of layer-based architecture pattern. It organizes the system into layers with related functionality associated with each other. Remember that each layer is independent. Each layer is independent and have separate functionality of their own. A layer provides services to the layer above it, so the lowest layer represent core services that are likely to be used throughout the system. So this means the services come from the lowest layer and it passes to the upper layer from that lowest layer, and then data proceeds further in layer base in layers. Example, the layer model of the system for sharing copyright document held in different libraries. This is the example. User interface. Then the second layer is user interface management, authentication and authorization. Either the user is authenticate user, authorized user or not. Core business logic, application functionality, system utilities, system support, So instruction or data passed from different layers. When to use? Used when building new facilities on top of the existing systems. When the development is spread across several teams with each team responsible for layer of functionality. When there is a requirement for multiple level security. Advantages allow replacement of entire layer so long as the interface is maintained. Redundant facilities can be provided in each layer to increase the dependability of the system. This is the advantage, that layer can be replaced easily without affecting other layers. And disadvantage is that in practice providing a clean separation between layer is often difficult, and high level layer may have to interact directly with the lower layers rather than through the layer immediately below it. Performance can be problem because of the multiple levels of interpretation of service request as it proceeds at each layer. So time complexity can be problem because data have to be processed one by one from each layer. And clean separation of layers are difficult. Remember one more thing, that the separation of layers are logical. We cannot see these layers. This is layer 1, we cannot see, but logically it is implemented in layer or through functions. One best example of layer based architecture pattern is OSI model. In computer networks we can see we have OSI model which consists of 7 layers: application layer, and then presentation layer, session layer, networks layer, transport layer, data layer, and physical layers. So one by one data pass from each layer, but we cannot see it physically. The separation is logical, and each layer is responsible for different functionalities, services, and different protocols are implemented on each layer. When there is a problem in one layer, other are not affected. So this is the advantage, but disadvantage is the time complexity can be increased. This is another example, just like OSI model. Compiler construction. When we talk about the compiler construction example, it is also the layer based architecture pattern. When we code a particular, when we write a particular code and then we compile, so the interpretation and compilation process of any tool from the backend libraries and conversion to the machine code is on the layer based architecture. Now come to discuss the repository architecture pattern. Here the subsystem must exchange data. This may be done in 2 ways. Shared data is held in a centralized database or repository. Repository means central database. Repository means a centralized database or server, and may be accessed by all the subsystems. This means in repository we must have a one central database system, and we have other subsystem that will approach this main centralized system or will be connected. When a large amounts of data are to be shared, the repository model of sharing is most commonly used, as this is an efficient data sharing mechanism. So this is the advantage when a large amount of data are to be shared. So the repository model of sharing is most commonly, and this is practiced in a centralized database systems. For example, if we take example of banking system, so each bank is independent, and we can say each and every bank is a subsystem, and they all pass their data to the one centralized system. And if other subsystem manipulates or change the data, so the other subsystem will also view their change. One other example of this is a hospital management system. For example, if we have a centralized database for the hospital management system, and one subsystem is a doctor, another subsystem is a medical laboratory, another is a pharmacologist, and fourth subsystem is account management, account department. So all these subsystem interact with the one repository system, and when one subsystem change their data, that data is changed for all the other subsystem also. So the question arises, why we need this centralized database system? So there can be many reasons, but the one main reason is that this same data is needed for all the subsystems. All the subsystems depend on each other indirectly. For example, here in this doctor or hospital management system, the accounts management depend on the doctor. Obviously, there will be fees the patient have to pay. So, who will enter that data? Doctor subsystem will enter that data. And if there is some OT operation charges, or obviously at the end, clean sheet will be given by the account department, and if there is any debt from the either the doctor subsystem or the pharma subsystem, drugs, medicines shop. So medicine shops inside the hospital is also connected as a subsystem. So all these are dependent on each other. Like we take other example of bank. I have account in one particular branch. I visit and deposit money, and it goes to central database system. So if I visit other subsystem and I view my or I withdraw or deposit money in other branch rather than the previous branch, so it will also retrieve the information from that centralized database. If it is not, so we must have, we then must depend on one particular subsystem. If every particular subsystem have their own database, so we will then depend on that subsystem rather than one centralized database. So centralized database is approachable from every subsystem. Description: all the data in a system is managed in a central repository or database that is accessible to all the system components. Components do not interact directly only through repository. This is the main point. Means the subsystems are indirect, not directly connected, independent. They are executed independently. One subsystem is not linked to other subsystem, but they both are linked or connected to the repository part or one central database. When to use? You should use this pattern when you have a system in which large volumes of information are generated that has to be stored for a long term. You may also use it in data-driven system where the inclusion of data in the repository triggers an action or tool. Advantages are components are independent. So we can easily install independent component subsystem in different sites or clients or different sites or branches, cities, countries. They do not need to know of the existence of other components. Changes made by one component can be propagated to all the components that I already discussed in detail. All the data can be managed consistently. Backups done at same time as it is all in one place. And disadvantage is the repository is a single point of failure. So problem in the repository affect the whole system. This is the main, because all the subsystems are dependent directly on one repository. If the repository fails or there comes some problem in the in that particular repository, so all the other subsystem will not work, will not functional, and can be down, can be failure, all subsystem can face failure. So this is a big disadvantage. Maybe insufficiency in organizing all communication through repository. There can be internet issue, there can be other communication issue, so or other issues that the number of users can increase, the load can increase, and this means alternately all the load from the other subsystems are indirectly or alternately on the same that repository system. Distributing the repository across several computers may be difficult. This is the disadvantage. So this is a way where different subsystems are distributed and connected to central repository. Now come to discuss the client server architecture. Distributed system model, which show how data and processing is distributed across the range of components. Set of standalone servers which provide specific services such as printing, data management. Set of client which call on these services. Network which allow. So client server shows there will be one client and one server. One client will approach one server. Client can increases, servers can also increases. So the server does not mean that the physical hardware will be distributed. Physical hardware can be one, database can be also one, but the logical partitioning or independent execution of services can be assured. So client server based architecture can be implemented on the repository architecture, but the one difference is that there is a one centralized repository in repository architecture pattern, and here the repository can be different. Each subsystem can be totally independent. The data can be independent. For example, I am the client, I have my own website, my own data. Other subsystem or other client has their own database or a server that I cannot see other clients' data, they cannot see my data. So this means in client server architecture, everyone have their own dedicated server or functionalities, data repository. In a client server architecture, the functionality of the system is organized into services. Server means it provides services, with each services delivered from separate server. Clients are the users of the services and access servers to make use of them. It is example of film and video DVD library organized as a client server, or we can take example of social media websites like Facebook. Everyone have their own page, web page, data. You can upload your data, or websites, university websites, college websites, business websites are all client server examples. When to use? Used when the data in a shared database has to be accessed from the range of locations, because servers can be replicated, may also be used when the load on the system is variable. Advantage, the principal advantage of this model or pattern is that servers can be distributed across the network. General functionality, printing services can be available to all the clients and does not need to be implemented by all the servers. And remember one thing, that we don't need to install the server. We just give rights to each user as a client, and the independent server is allocated to them. Disadvantage, that each service is a single point of failure, so susceptible to denial of the service, attack on the service. Security is a big problem. Performance issue, if the server down, so all the user must have to wait Availability is a big problem. This is example client 1, client 2, client 3, client 4 through internet browser. They connect with their own different servers. Client 1 server is library catalog, client 2 server is a video server, film store, photo store, and then film and photo info. Everyone is independent. So now you must have know what is the difference between client server and repository. In repository there is one centralized database, all data comes there, and here we can see independent servers are allocated and a type of independent databases are assigned to them. Database can be one, but the one cannot see other data. If we give rights to more than one client that they can see data, obviously we can give the rights, but the server will be one for many clients. Pipe and filter architecture, functional transformation process, their inputs to produce outputs may be referred to as a pipe and filter model. What does filter means? Here core functionalities in one unit or subsystem will be operated on a particular data, and then data will be processed in a pipe channels, and then will be go to another filter, and then will be processed just like filter water. What does filter water do? Filtration plant do. Water comes in a pipe and then filter and go in another pipe. Not really suitable for interactive system. The processing of data in a system is organized so that each processing component or filter is discrete and carries out one type of transformation. Means the data is one type and then processed from different filters through pipes. When commonly used in data processing application, batch and transaction based system where the input are processed in separate stages. Advantage: easy to understand and support transformation reuse. Workflow style matches the structure of many business process. Evolution by adding transformation is straightforward, can be implemented as either a sequential or concurrent system. Disadvantage: the format for data transfer has to be agreed upon between communicating transformation. Each transformation must parse its input and unparse its output to the agreed form. This is the example. Payment in bank. If you visit the bank and if someone send you money from foreign, you have to take money, and different data has to be processed from different units. First you go to one counter, then after processing the data you go to other counter, then after processing the data you go to other counter, and then you get the money. So receipts are issued and payments are given after passing from different filters. So this was all about the architecture pattern. Hope you enjoyed the lecture.